In this example, we will find all solutions for the equation 5 cosine squared of x is equal to 5 sine squared of x minus 3. We will keep all answers exact. I will say up front here that I'm going to progress through this equation in one particular method, but there are multiple ways to address this. In this case, I see 5 cosine squared of x is equal to 5 sine squared of x minus 3. Now, that's a problem for me because even if I want to try to use substitution to make this equation look a little bit cleaner, we can really only do that when we have the same trigonometric function. Currently, we have a cosine of x as well as a sine of x. So, we can't do substitution quite yet. However, we should have a few different tools at our disposal that will allow us to rewrite one of these terms in terms of the other one. For example, one thing that you could use is the Pythagorean identity for sine squared and cosine squared. We know that sine squared of x plus cosine squared of x is equal to 1. This is the Pythagorean identity. So, if I use this, I should be able to replace one of these trig functions with the other. For example, let's say if I wanted to replace cosine squared, I can use this Pythagorean identity to rewrite cosine squared as 1 minus sine squared of x. And that would allow me to take this expression, 1 minus sine squared of x, and replace that where I have cosine squared of x in the original question, since I know that they both equal each other. So then I can take 5 cosine squared of x equals 5 sine squared of x minus 3, and replace this cosine squared of x term with 1 minus sine squared to get 5 times 1 minus sine squared of x equals 5 times sine squared of x minus 3. It is always good to look out for trigonometric functions taken to a second power. If you do see those functions taken to a second power, one of your first thoughts should be a Pythagorean identity. They won't always solve the situation you're working with, but they're a good thing to lean on to. So let's clean this up a bit. Let's factor that 5 through. So I get 5 minus 5 sine squared of x is equal to 5 sine squared of x minus 3. And then because I see multiple trig functions and they're on different sides, let's see if we can move it all to the same side. So I'm going to subtract 5 sine squared of x from both sides. And I'm also going to add 3 to both sides. That will give me 8 minus 10 sine squared of x is now equal to 0. That's a little bit nicer. Now at this point, if you still want to do substitution, you can, but you probably don't need to here because we really only have one term that involves a trigonometric function. So, all we really need to do here is work to get sine of x by itself, and then evaluate x from there. So, if I move the 8 back over to the other side, I'll get negative 10 sine squared of x equals negative 8. And then we could divide by negative 10 to get sine squared of x is equal to negative 8 divided by negative 10 will give you, if you simplify, positive 4 over 5. One last thing to get sine of x by itself, I would need to take the square root of both sides. That will give me sine of x is equal to the square root of 4 over 5. You can simplify if you want. However, because we took a square root, that also means we need to consider sine of x also equal to negative square root of 4 over 5. From here, though, we now should be able to solve to get x by itself using an inverse trigonometric function, in this case, arcsine. Now, let's focus on the first set. Sine of x equals the positive square root of 4 over 5. I don't recognize that ratio of square root of 4 over 5 from the unit circle. I know that it defines a realistic triangle because that ratio is less than 1. So that is a real triangle, I just don't know what angle measure this would relate to. However, we do not need to know what angle measure it is, even if the question asks us to keep all answers exact. That does not mean it needs to be an exact radian familiar values like pi over 3 or something. When we take and solve for x in that first set by taking an inverse sine, our first set will look like arcsine of square root of 4 over 5 plus 2 pi k. And keep in mind, when you take an inverse trig function, you typically get multiple solution sets, particularly with sine and cosine. One solution set is made by arcsine of square root of 4 over 5 plus 2 pi k, but you should also have another solution set that is pi minus arcsine of square root of 4 over 5 plus 2 pi k. So that'd be the first two solution sets from the top. We should also get some infinite solution sets from the second equation here, where we had negative square root of 4 over 5. However, the answers are going to look very similar here. We're going to get arcsine of, instead of positive root 4 over 5, we get negative square root of 4 over 5 plus 2 pi k, which you can also rewrite if you would like to apply the odd concept for arcsine, as well as pi minus arcsine of negative square root of 4 over 5 plus 2 pi k. And that would be all we need, keeping in mind that k, in all cases, is an integer. Now, what I've demonstrated is one way to work through this problem. If you instead replaced sine squared at the beginning of this problem with 1 minus cosine squared, then you're going to get similar kinds of answers involving arc cosine instead. We also could have used another identity if, for example, at the beginning we had moved 5 sine squared to the left side of the equation to get 5 cosine squared of x minus 5 sine squared of x is equal to negative 3, or 5 times the quantity cosine squared of x minus sine squared of x is equal to negative 3. We could have replaced cosine squared of x minus sine squared of x with a double angle identity for cosine, as this is one of the double angle identities for cosine. That would have also led us down a different path. However, regardless of which path you take, the solutions that you get, even if they look a little bit different, are still going to be the same. So if you had used 1 minus cosine squared earlier and got functions involving arc cosine, or if you used the double angle identity of cosine here, it doesn't matter. You're going to get the same answers regardless. If you wanted to go through and you did this a different way, by all means, go ahead and approximate some of your solutions, and then go ahead and approximate the solutions that I have shown here involving arcsine. You should find that you're going to have the same solutions. They may be in a different order, but you'll have the same solutions.